Identify the hybridization state and geometry of each carbon atom in the following compounds. So we have two compounds here and we have to figure out the hybridization and geometry. First, let's start with hybridization. Here I have a little chart that will help us to determine hybridization of every carbon atom. In order to do that, first we must figure out steric number, which is number of attachments plus number of lone pairs. And then if our steric number is 2, hybridization is sp. If it's 3, it's sp2. And if it's 4, it's sp3. So let's go ahead and look here. If we look at this carbon, we ask ourselves, how many atoms is this carbon attached to? This carbon is attached to 1, 2. It is attached to 2 other atoms. How many lone pairs does it have? Lone pairs is 2 electrons. We are not shown any electrons. This carbon is already happy. It has a full octet, so it has 0 lone pairs. Actually, none of them will. I can see here right away that we're not shown any lone pairs. None of them have lone pairs. All of these carbons have 4 bonds already. So this carbon, like we said, is connected to 2 atoms and it has 0 lone pairs. That means its steric number is 2. What does it mean? That means the hybridization for this one must be sp. Let's continue. This carbon is connected to 2 atoms, no lone pairs, also sp. And you can see this molecule is symmetrical, so on the other side we have the same sp, sp. And now let's look at this carbon. It's connected to 1, 2, 3 atoms. So that, and it has no lone pairs. 3 means sp2. So this carbon is sp2, and so is this one. Again, this molecule is very symmetrical. Let's go to this molecule. This carbon is attached to 1, 2, 3, 4. Its steric number is 4. That means it's sp3 hybridized. Every carbon here is the same, so all of the carbons are sp3 hybridized. A lot of symmetry in our molecules. Now we are going to figure out the geometry or the shape of each carbon. So if we are attached to 2 atoms, we're trying to find in my chart if my atom is attached to 2 atoms with no lone pairs. How do we read this chart? Purple is the central atom. The blue dots are atoms that is attached to. And then if we see 2 little black dots, that's the lone pair. In our case, our carbon is attached to 2 atoms with no lone pairs. So we see that if my central atom is attached to 2 atoms, no lone pairs, this is linear. So for sp, all of these carbons, they are going to be linear. Now, what about sp2? This carbon is attached to 3 other atoms and no lone pairs. What happens if I'm attached to 3 other atoms with no pairs? This is trigonal planar. So my shape here is trigonal. Sorry for my handwriting. Planar, trigonal planar. These 2 carbons are trigonal planar. Let's continue. This carbon is attached to 4 things, no lone pairs. So let's find, where do we see that the central atom is attached to 4 other atoms, no lone pairs? That's tetrahedral. So my sp3 will be tetrahedral. So sp is a linear, sp2 is trigonal planar, and sp3 is tetrahedral. This is Mayya. Let me know what you're working on this week. What are you studying? What topics are you struggling with? Maybe I'll make a video with that.